They told me I had to go to training today. And I was like, what? And they were like, yeah. And I was like, what? And they were like, yeah.
But we can't have a sub on a Monday.
I'm going to need you to be on your best behavior. If you're not, you'll break your poor teacher's heart.
But for real, let's get started. We are doing a math lesson today. We're going to start out doing it in a whole group. There's going to be several moments where your teacher can pause the video so that you guys can practice, and then we will restart and we'll check some of our answers, and I think you guys will be pros by the time we're done. So let's get started. Everyone's Chromebook should be put away and everyone's desk should be cleared off. In a little while, when we pause the video after you've watched me demonstrate a few, then I will have you get up and grab dry erase boards and markers to get started. Please don't forget to put the lids back on your dry erase markers, guys. We're running short. Hey guys, I want you to take a minute and see if you can hear the sounds of the orchestra playing. While you're listening, I want you to be thinking about how many people it takes to make up an orchestra, how many instruments, how we could break that down, how we can hear the sounds of each one of those instruments playing. And I want you to be thinking about our objective that you saw over on the board. The same objective that we started on last week, which is classifying rational numbers. We looked at it in a variety of ways. We made our Venn diagram. We talked about how numbers can be whole numbers, integers, rational numbers all at the same time. We talked about what makes a rational number different than just a regular whole number and different than an integer. And we also started generating equivalent fractions and decimals. So we did something very simple last week. We took simple fractions like 1/6, and you guys worked to convert this into a decimal. And so the way you did that is we labeled the denominator and the numerator, and we said the down in the dirt denominator goes at the door. And so we put the denominator at the door and we put the numerator inside the house. Well, we could look and see, hey, this 6 cannot divide into this 1. So I can add a decimal, take it to the roof, and add a 10 or add my 0 to make this 10. Now I just forget the decimal is not there for my dividing purposes. So how many times will 6 go into 10? You had told me that it would go in 1 time, and when I subtract, I get 4 left over. Well, in the past, this would be our remainder. And if we had a number left over down here, then we couldn't divide into it. But this year, we're doing something called annexing zeros. That means we can add some zeros up here as many times as we need to in order to get a number that would be divisible by 6. So now we can think, how many times will 6 go into 40? I know that 6 times 6 is 36, and that gives me a remainder of 4. Now my difference there is 4. And if we kept dividing this out, we would find out that this 4 is going to continue repeating every time I annex a 0. And so we would write this as 1600ths, and then we would put the little bar notation over the 6, and that helps us to know that this is a repeating decimal. Last week, we also worked with some terminating decimals. So this week, we are moving on to something a little bit different. I want you to think back to that orchestra that you just heard playing. And I want to talk to you about some parts of the orchestra. For example, you may hear brass instruments in the orchestra. You can hear some percussion. You can hear the woodwinds. These are the instruments that require the wind to play. You blow into them. Lots of different ones that don't fall under the brass category, like the flute, the clarinet. And then we have string instruments. These might be guitars, they might be violins, cellos, a lot of different instruments. And so I want to talk about how many people in each one of these sections plays these instruments. And so under the strings, I have 0.31. And there is another way that I can say this decimal, and we're going to work with that here in just a few minutes. And under my woodwinds, I'm going to put 0.29. That represents how many people in the orchestra play that instrument. Under the brass, I have 0.25. And under percussion, I have 0.15. And so I am going to look at each one of these instruments and I'm going to break it down into a fraction so I can figure out which fractional part of the orchestra plays one of these instruments. And so, in order to do that, I want to just look at this first one. Let's just look at brass. I want you to think about your place value chart. I want you to think about what happens after I have gone my thousands place, my hundreds, my tens, and my ones, and now I have a decimal point. And last week you told me that this is the tenths place with a TH, and this is the hundredths place. And some of us needed refreshers that we don't have a ones place when we have passed the decimal over to the right. And we have the thousandths place, and so on. We would just continue, just like our regular whole numbers side of our place value chart. We continue doing that for our decimals over into our rational numbers, counting the exact same way. So we are going to stop today with hundredths or tenths, hundredths, and thousandths. So let's take a look at these. And this is going to help us when we read this decimal. So if I were to read this decimal, what would this decimal say? Go ahead and try. So you should have said 25 hundredths. And the reason I say hundredths is because if I were to write this number under my place value chart, where would my last decimal place fall? It falls in the hundredths place. So I can say this decimal as 25 hundredths. Now I want you to think 25 hundredths in your head. And I want you to think about how you could represent 25 hundredths as a fraction. And so last week we talked about having a number like 9 tenths, and you told me you would represent 9 tenths, the fraction, as 9 over 10. So if we use that same technique to try to change 25 hundredths into a fraction, then we would end up with 25 over 100. 25 hundredths. Now, I have taken this decimal and I've written it as a fraction, and it's a great fraction. There's only one problem with this fraction. It needs to be in a more simple form. I can simplify this fraction. So I know that you guys have practiced simplifying fractions in the past, but it may be something that's a little rusty to you because I know how much some of us are really struggling with being able to divide. And in order to simplify fractions, we have to know those math facts. We have to know division and multiplying. I have put some games on your Google Classroom, and I've even put a video that's really great about simplifying fractions. So I would really suggest that you go and take a look at that when you get a free moment. When you get some free time, maybe during your pirate blocks today, maybe at home this evening, or sometime this week, definitely take a look at that because it's going to be very handy for you to use this week during math and in the near future. Okay, so I have 25 hundredths and I want to talk about how I can simplify this. Now, when I'm looking at 25 hundredths, my brain starts to engage and I already know that I can divide 25 into both of these numbers because it's broken down just like it would be a dollar bill. We know there's 100 cents in a dollar, and we know how much of a fraction of a dollar 25 cents is. So 25 could divide into 25 one time. So I would get 1 on the top. And 25 could divide into 100 4 times. So I have my 4 as my denominator down in the dirt denominator. So I'm left with a fraction of 1/4. So I know that 25 hundredths written as 0.25 is the same as 25 over 100, which is the same as 1/4. So I've found some equivalent fractions here. I know that 25 hundredths is equal to 1/4, and I know that this fraction is equivalent to this decimal. So let's try something a little bit more difficult. Let's look at the next one. I have 0.15. Now I want you to tell someone at your table how you would say this decimal. Okay, you should have said that this is 15 hundredths because once again, if I were to replace this 0.25 with the 0.15 under my place value chart, my last decimal is going to end at the hundredths place. And so I would say this is 15 hundredths. Now, a few minutes ago when we were discussing, you told me that 9/10 would be written as 9/10, and that 25/100 could be the same thing as 25/100. And that's going to continue here. So if we would say this fraction as 15/100, then I could write it out as 15/100. So now I need to simplify this into the most simple form. And I know it's not simplified yet. Just by looking at it, I see 100 here, I see 15. I know that there are numbers that can divide into both of these. And so I automatically try to start with 5 when I see that they are both divisible by 5. I know that if there's a 0 at the end, that it is divisible by 5, and this one ends in a 5, so I also know it is. So I'm going to try dividing these by 5. So if I divide 15 by 5, I'm going to get a 3. And if I divide 100 by 5, I'm going to get 20. It makes me think in terms of nickels. If I had 100 cents and I divided it up in nickels, how many would I have? And I would have 20. And so I have 3/20ths. And I want to think and see, is there anything that is any more simplified? Can I simplify this fraction anymore? And when I think about it, I can't, because the only thing that I can think of that will go into 3 and 20 is the number 1. So my brain thinks 1 and done when I've reached 1 as being the only number that can go into 3 and 20 equally. So you have simplified this fraction. I had 15/100ths, and we know that's equivalent to 3/20ths. And we could also say that as 15/100ths when it's 0.15. Okay, at this time, I'm going to ask for the video to be paused. And while the video is paused, I want everyone to get out of their seats. I want you to grab a dry erase board and a marker and meet back at your seats. And let's do it very quickly. And when you are back at your seat and ready, the cap is on your marker, then your teacher will know to start the video. All right, I think we're ready to roll. All right, we're going to practice on our boards with a few problems. And the first one I want you to do is 0.6. And I want you to decide, how can I say this decimal in word form? And once I've matched it up with my place value chart, I know how I will say this decimal in word form. And then I want you to think about, how can I write this decimal out as a fraction? And that's the very first step I want you to do. So go ahead, say this fraction out as a word form, and then I want you to write it as a simple fraction. Okay, so you should have matched this up with your place value chart, and you should have said 6/10, because that is where the last decimal place, last place falls after the decimal. And so if I were writing this out as a fraction, I would write it as 6/10. Now there's one problem here. This is a great fraction again, but is not in its most simple form. And I know that when I look at this fraction and I can see that both the top and the bottom are equal numbers. So my brain automatically knows that 2 can go into both of these numbers. And maybe there's something more that can go into these. But I want to show you how we could do this in a more simple way to simplify a fraction. And it'll be very easy when the fractions are smaller like this, but as our fractions get bigger and bigger, it might be something that helps you along the way. Now, we've talked about the different ways we can represent fractions. I can do it as 6/10, or even a 6 with a slash and a 10, like this. And so when I put my fraction like this, it gets me to thinking a little bit more. I don't mind if you keep it this way, but we're going to do something called a fraction ladder. And so with a fraction ladder, I have my 6 over here and I have my 10 here. And around my 6 and my 10, my numerator and my denominator, I'm going to draw what kind of looks like an upside down division bracket. And I'm going to draw this bracket because I'm going to be doing some upside down dividing. So I want to think of a number that could go into both 6 and 10. They're both even, so I know automatically that 2 can go into both of them, and that's always a good place to start. So I'm going to put a 2 over here, and I'm going to see how many times it'll go into each one of these numbers. So 2 can go into 6 3 times, and 2 can go into 10 5 times. And so I have simplified this fraction out first by dividing by 2. Next, I'm going to add another bracket, and I'm going to see if there's another number that I can use. Well, in this case, this is a very simple fraction, like I said. these numbers can only be divided now by the number 1. And so I know when I'm at 1, I'm done, 1 and done. And so I know that this is now my new fraction. I added my slash in the middle, and I can write it as 3 over 5, 3/5. And so you have taken the fraction 6/10 and simplified it to an equivalent fraction of 3/5. So let's try another one that might be a little bit bigger where the division ladder might help you out. I want you to do the decimal 0.45. 0.45. And once you get 0.45 converted into a fraction by placing it under the place value chart, listening to the word form, then writing it as a fraction, I want you to think if this fraction is in simplest form or not, and if it is not, how can you put it into simplest form? I'm going to ask the teacher to go ahead and pause the video now while you take a couple minutes to work, and then when about most of the class is finished, then you can play the video again and we'll go over. Okay, let's take a look at this. So if you match this up to your place value chart, you would notice that the last decimal point ends at the hundredths place. So you would have said this decimal as 45 hundredths, which we would write the same as 45 over 100. 45 over 100. And I can look at this fraction and my brain knows that it's not simplified because I can see that I know at least 5 can divide into each of these numbers. Maybe there's something more, but we're going to start with 5. And you may choose to set it up as just dividing 5 into each of these numbers and seeing what you get, and then you can go on and on as many times as you need to. I know my multiplication facts, and I know that 9 times 5 equals 45. So I know that 5 will go into 45 9 times. And I know that 5 will go into 100 20 times because, again, I'm thinking like nickels. And the most simple form I can get of this is 9/20ths. Now, that is not always going to be the case. Sometimes I'm going to divide 5 into it, and there are going to be more numbers that can still divide into it evenly. In this case, 9 is that prime, it's not a prime number because 3 can divide into it. But in this case, 9 only has the divisors of 1 and 3. So let's keep moving on. Let's try another one. If you got 9/20ths, give yourself a pat on the back. And let's move on. Let's try another one that might need a little bit of simplifying where we can break this down. Let's try something a little bit bigger, 0.375. 0.375. I'm going to give you just a minute. I'm going to ask the teacher to pause the video again. When the majority of the class has completed this, then you can replay the video and we'll go over it. Okay, let's talk about this number. When I match it up to my place value chart, I can see that the last decimal place ends at the thousandths. So I would say this number as 375 thousandths. Be careful that you are not calling this number 375 thousandths because that's not how we say it. And only belongs where the decimal point is. So we would say this number as 375 thousandths. So if you wrote this out as a fraction, you should have gotten 375 over 1,000. 375 over 1,000. Now, I absolutely know that this is not in the most simple form. So I'm going to go ahead and set this up into my fraction ladder. So I'm going to put 375, and I'm also going to put 1,000, and I'm going to put my bracket around it. And I want to see how many times I can find a number that will divide into both of these. So let's just start with, what if we start with something simple? What if we start with something simple like 5? Because we know that 5 will go into both of these. And maybe my brain is just not thinking today and I need to start simple. So I need to think, how many times will 5 go into each of these? Well, it might be helpful for you to divide this out. So if I had to figure out how many times 5 goes into 375, I can write it out like a simple division problem and I can work it. Don't be afraid of doing these steps. Don't give up too early. How many times can 5 go into 3? We know it cannot, but 5 can go into 37, and it can go in 7 times because 5 times 7 is 35. When I do that, I'm going to get 2 left over for my difference. And then I can figure out, I can bring this 5 down because I know 5 can't go into 2. How many times can 5 go into 25? It evenly goes in 5 times, and that gives me a remainder of 0. So I know that 5 can go into 375 75 times. And then I want to figure out how many times can 5 go into 1,000. And so I want to show you this way, but I also want to talk to you about a trick you may already know. 5 cannot go into 1, but it can go into 10 2 times. And that gives me 10, which is 0. And I got to still bring these zeros down. And when it will not go in, I will just add my zeros here and I get 200. But another way I can think of this, I can isolate these zeros here and I can ask myself how many times will 5 go into 10? 2 times, and there are 2 zeros left over, so I can just add those 2 zeros to the end. So now I'm looking at 75 and 200. So let's add another step on our fraction ladder. And for my next step, I know that there's something that can go into these again. I could do 5 again if I'd like to do 5 again. Let's do 5. Let's just do 5 for the fun of it and see how far we can take this out. Some of you may have already noticed that 25 could also go into both of these numbers, and that would get us there much quicker. But some of us struggle to know that 25 can go into these larger numbers. I mean, it's more difficult working with the larger numbers. So I want it to be as simple as possible. So I'm going to think about how many times will 5 go into 75? Well, I know that 5 will go into 50 10 times. And I know that it will go into the remaining 25 5 more times. So I know that 5 will go into 75 15 times. And I know that 5 will go into 100 20 times. So it will go into 200 40 times. All right, let's look at these numbers. Now I'm sitting with 15 and 40. Can I go any lower? 2 cannot divide into this, but I already know that both of these numbers are divisible by 5 once again. So I'm going with 5 again. 5 will go into 15 3 times, and 5 will go into 40 8 times. So now I have the simplest form I can get because the only thing left is 1, and I know when I'm at 1, I'm done. So now I have 3 eighths, and I have simplified the fraction 375 thousandths as 3 eighths. And so I have taken 375 thousandths and I have generated an equivalent fraction for that. All right, let's try something a little bit different. Let's try taking a decimal that may have a whole number in the front, and let's try changing it into a mixed number type fraction, and then seeing if we can convert that into a decimal. So what if I have a number like 9.25? 9.25. Now I'm saying, I'm sorry, let me change that to 9.85. I'm saying point, and I absolutely know that's not the way to say this number, but I'm trying not to give that away for you. So I see 9 a decimal point and 85. So I want you to take just a minute and think about how would you say this number as a decimal. Go ahead and do that. Okay, so you should have said 9 and 85 hundredths because the last decimal place ends at the hundredths place. And we say 9 is a regular whole number and represents the decimal. So 9 and 85 hundredths. So if I were going to write this out as a fraction, I would write it as a larger 9. It's going to be a mixed number, and 85 over 100. If I say this fraction the same, it's true that I'm also going to say 9 and 85 hundredths, just like I would say the decimal 9 and 85 hundredths. So they are the same number. They are equivalent. One is just a fraction, one is a decimal. And so now I need to simplify this. My 9 is going to stay just the way it is. It's going to stay the same. But I need to simplify the 85 100ths. And so in order to do that, I know 5 can go into each of these, so I'll just try it with 5. And let me see how many times I can get 5 into each one of these numbers. And I know that 9 or 5 will go into 85 17 times, and 5 will go into 100 20 times. That's been a popular number today. And I just continue with my 9. So I add it there at the front, and I'm left with 9 and 17 twentieths. 17 twentieths. So 9 and 85 100ths is equivalent to 9 and 17 twentieths. And it's very simple and basic the way that we work that out. All right, I'm going to give you one, and I want you to practice it on your board. Let's do the fraction. You know what? Before we do that, let's review just a little bit how we went from fractions to decimals. I want you to remember, if I give you the fraction 3/5, I want you to take this fraction. I want you to put the denominator at the door, that down in the dirt denominator, put it at the door, put the 3 in the house. I want you to solve this and get a decimal. And then I want you to write your decimal as a fraction. And then I want you, when you get your decimal, I want you to write it as a fraction. Then I want you to simplify the fraction. So I'm going to have the video pause, and I'm going to let you go through this. And when the majority of you are done, then you guys can come back and you can watch us do this together. Okay, so let's talk about how you did this. You should have put your down in the dirt denominator at the door, and your 3 should have gone into the house. Now, 5 cannot go into 3, so I hope that you added your decimal point in your 0. Remember that some people like to put in this space saver here, this 0. And now we can divide 5 into 30. And 5 will go into 30 6 times, and it is an even 30. So I'm going to be left with 0 as my difference. And I can stop there. I've got 0.6. And now you should have taken this number and thought about how I would say it as a fraction, or as in my place value. And we would say it as 6/10. So if you said this number as 6/10, then you have created a fraction that is equivalent to 3/5. So 3/5 is the same as 6/10. Now, if you have already caught on to this part, you know that 6/10, if I simplified it, I'm going to get 3/5. And the way I would do that is I could divide each one of these by 2, because it's the number that comes to my head first, and I'm going to get 3/5, which is the simplest form. It is the same as the fraction that we started with. We just found a fraction that has an equivalent decimal that also has another more simplified, a greater fraction. And when we simplified it more, we come back to our 3/5. So you can see how they're all equal. Let's practice with another one. Let's do 14 over 25. Now, this one's going to take you a few more minutes, a little extra time. I want you to put 25 at the door, 14 in the house, and I want you to solve this. Come back to the video when you're ready. Okay, so you should have put 25 at the door and 14 in the house. And I know that 25 cannot divide into 14, so I need to add my decimal and my 0. And now I know that 25 can go into 140. I'm thinking in terms of quarters here. It can go into 100 4 times. It can go into 125 5 times, but I can't add one more because I would be at 150. So 5 times would give me 125. And when I subtract, I have to go next door, I have to borrow. I'm going to get 15 as my difference. 25 cannot go into 15, and we don't deal with remainders anymore. We add and annex a 0, and now I'm left with a great number of 150, because I know 25 can go into 150 equally. And we said just a minute ago that it would be 6. So 150, and I have 0 as my difference. I can stop there. Now I'm left with 56 100ths. And I'm sure you discovered if I simplified that, I would be right back to 14 25ths. All right, let's see what we can do. And let's see how you guys are looking time-wise. And if we have a little bit of time, you guys can go on. If not, we'll go ahead and you can go ahead and stop the video now. But here's what I want to do. I want to give you a mixed number like 1 and 3/8. So let's take 1 and 3/8. And I want to talk about how we can split this up and we can simplify it a little bit. What if I wanted to say that I need to represent this as a decimal? I want to represent this as a decimal. So here's what I would need to do. I'm going backwards now. I'm going from a fraction to a decimal, but I'm doing it with this one here. And so the way I would do that is I would isolate this one. It's over here now and it's by itself, and we're just going to let it sit there for a few minutes. I can just work with this 3/8. And so I would put my 8 at the door and my 3 in the house. I know it can't divide, but my 8 can go into 30. And 8 can go into 30 3 times, and it's going to leave me with 24. And so when I subtract to get my difference, I have 60. Now I can keep annexing zeros as long as I need to. You need to start thinking about how many times could 8 go into 60. Now, some of us, we're really getting tricked up on our 8s still. You know your 9s now. If I were to try 8 times 9, 8 times 9, I'm going to get 81. And I know that's too many. So let's take it back a few steps. You know that 8 times 4 is going to, 8 times 5 is going to give you 45. And that's not quite enough. So somewhere in the middle there is what we're shooting for. So if we did 8 times 7, that would give us 56. And I'm left with 4. Now I can annex another 0. 8 can go into 40, an equal number of times, and it's 5. So that gives me 40, and I'm left with 0. So I can stop there. Now, don't forget about this 1. It's still sitting over here. I just moved it on by itself. But I have taken 3/8 and I've converted it into a decimal. And I got 0.375. And so 0.375 can be said as 375 thousandths. So if I were to write that out, 375 thousandths. Now I have this big fraction, right? I have this big fraction that I could convert out if I wanted to. I know that it would get me right back to, I could simplify out and get me right back to 3/8. But what I want you to see is this 0.375. And so 0.375 is what I got when I took my fraction and converted it to a decimal. Now, I'm not forgetting my 1 over here. It's time for me to bring it back. And if I put this 1 here, it's my whole number, 1. I can add my decimal to the end, 0.375. Now, I can see that 1 and 3/8 is the same thing as 1.375 or 1 and 375 thousandths. There's the 375 thousandths. It is equal to 3/8. So essentially all I did was took 3/8 and I multiplied it out, and I got a great big number until I got 1,000 on the bottom. So it was easy to say. And that was one way that we just went around it. We used the method that we know. We took our denominator, put it at the door, we divided it out, and we were able to see that we got 375 thousandths. And when we put that with the 1, the whole number 1 that we had sitting over here on reserve, you can't forget about that, because we can't end with just 375 thousandths. We have to add that 1 back in there. All right. At this point, if you are almost out of time, you can go ahead and end the video now. Thank you guys for paying attention. If not, I'm going to go ahead. I'm going to leave several problems here on the board for you guys to work out. Try your best. Do some practicing. You may either work them out on paper or on your dry erase board, but I do ask that you return your dry erase markers with the lids on back to the drawer, and that you return your dry erase boards back to the shelf when you're finished. So let's get started with a couple that you can try to solve on your own. Go ahead and try 0.4. Convert this into a fraction and then simplify it if it can get any simpler. Once you've completed that one, I want you to try 0.64. Think about how you would say that. And next I want you to try a mixed number. I want you to try 2.75. Put that 2 to the side, reserve it. I want you to take the 75 hundredths and I want you to convert that into a fraction and see if you can solve that. And then let's do a fraction. Let's do an improper fraction. Let's do 7/10. halves. 7 halves. And I want you to work this out the exact same way that you know how. When you get your decimal, it's going to have a whole number in the front. So I want you to take that whole number. I want you to use it at the front of your decimal. And then you can even change this back into a mixed number if you can figure that out. So let's go ahead and try these out. If you get them and you're feeling really good about that, I want you to think about how you would rate yourself. Are you a 1? You're really stuck. Are you 2? You're kind of getting it, but you're going to need some more time with me tomorrow. Are you a 3? You have got this and you feel really good about it. And or are you a 4? You feel like you are a master at this skill and you feel like you could help me tomorrow when I reteach this. So I want you to be thinking about, where do you fall here? If you have more time, I'll write out a few more math problems and I'll leave them with your teachers so that you can solve them. I'll see you guys tomorrow.